Okay, it is getting recorded now.
Ma'am, please share the link.
This recording will get uploaded later. Okay.
Okay.
Okay, so we were discussing. So here 0, 1 is having the value 2. So we are creating the edge between 0 and 1 vertex. Now for 0, 2, we are having 4 here, right? So from 0 to 2 will be 4. Then 0 to 3 is again 0. So no edge will be there. Now here 1 to 0. So you have already created the edge. Now 1 to 1 will be 0 of course. Then 1 to 2 is 1. So 1 to 2 is having edge 1. Then 1 to 3, 5. Similarly for 2 0, it is already there. 2 1, 2 2 and 2 3 will be having 5. 2 3, okay, 3. Okay, clear how we are creating the graph from a matrix, right? Is this clear?
Ma'am, can you explain this again?
Okay, see what happens is we always deal with the adjacency matrix when we are creating a graph. Okay, so this is a square matrix to represent the finite graph. So each element in the matrix will represent the weight. So if I write something graph I j, the value will be the weight of the what edge, right, connecting the two vertices. So for unweighted graph, you represent the edge with infinity or 0 you can write. Let's say you have the n vertices. So the matrix will be having n cos n, right? N cos n matrix will be there, and graph ij represent the weight of edge from vertex I to j. Okay, and this is
Yes,
what?
ma'am.
This is the way. So here this represent I, this represent j, and this is w. So using this, we have created a graph which is having 4 vertices and the edge is weighted, right? Here the edge are weighted. So this is called as weighted graph. So to find shortest distance and time, we use different algorithms like DFS, depth first search, breadth first search, disaster. Okay, then we have a Bellman Ford. These are the algorithms used. So So in the lectures you have seen that we are dealing with trains and stations, right?
Yes, ma'am.
So we'll be creating a graph which is trains and it is having data like this. Okay, let's say this is start station which is A and then it's have end which is B. Okay, something like this. So what is this? What is this? Dictionary, right?
Yes, ma'am.
Nested dictionary we are using. So for creating graph, we use empty dictionary, correct?
Yes, ma'am.
Clear? Till now it is clear, right? What is adjacency matrix, how we are creating the graph.
Yes, ma'am. Clear.
Ma'am, but what
Mhm.
is weight refers here?
Weight is this, the distance from this vertex to this vertex.
Okay, means it
Edge,
indicates.
the edge is carrying the weight.
Okay.
Ma'am, then how
Okay.
is the distance between first and third? 5.
Distance between first and third. Here one tree is holding the value 5.
Ma'am, I didn't get it. First and third number in the same row, same column.
No. Graph of 1, 3. So this will be I, this will be J. Row and column.
Okay, yes, ma'am.
Okay. Anyone else? Understood? Okay. See here. We are creating this trains is already a graph here. Okay. So suppose trains is a dictionary. So suppose trains is a dictionary and then you are creating a dictionary station, right? Then here you are iterating through every key of the trains, and then in station dictionary you are holding those values, right? So what this will do here, it will create stations and it will be having unique values, unique stations, right? And those values will be set to true here, right? Understood, right?
Yes,
Yes,
ma'am.
ma'am.
Now n is taking the length of the keys of stations. So what n will be holding? 2, right? Then direct what? This is creating a matrix of n cross n. So direct will be a matrix of 2 cross 2. Then here you are creating another dictionary which will be having the station index. So this will do something like this. Okay. Okay, it's starting from 0. See here what I am doing. I am reading every key of the station, right? So in station I am holding these values A and B. So when I will be reading A, that A will be setting the value 0 here, right? Then I will get increment, and for B it will set 1. Correct? Understood this? Now next here this is going to read every key of train's dictionary, right? Train 1, train 2. And it will be holding the values in I and j. Okay, so if this is written here something like this, then I will be taking the value 0, correct? Start station is A, so it will take 0 I, and j will take 1, right? B is 1, so it will be taking 1. Then you are uh, in this direct matrix. So this is 0 1 0 1. So this direct matrix for 0 1. So for t train 1, I will be having 0 and j will be having 1. So direct 0 1 will take value 1. So this will be 0 before. When you will be creating the matrix, it will be 0 initially. Then you replace the value to 1. Again, you will read for the second train, and I will be set to tell me.
Ma'am, this I and J, to what values are they pointing? Can you please explain that? I didn't understand.
I is the rows. I is the rows and the J are the columns.
No,
This
ma'am,
is row,
how
this
are you
is column.
finding direct 0, 1 value?
Here it is written the STN index dictionary. If you look at this, the value which is stored in start. So what are you storing in here? For you are storing the value 0, right? So if
Okay.
something is written like this, so what this indicate? Trains T start.
Ma'am, in
So
the
this
train,
is train 1,
train
right?
dictionary.
And
Yes, ma'am.
start will be A, right?
Yes, ma'am.
So what is here A holding?
0.
0, right? The value is 0. So I will be carrying the 0 value. Then similarly for J, you will take end station. So this will give you 1, right?
Yes,
Because end here is B.
B.
Understood?
Yes, ma'am. Ma'am, in the direct 0, 1, how are we getting 1? Like, after finding out I is equal to 0, J is equal to
Here you are assigning the value 1.
1. Okay.
okay.
Yes,
Okay. So for train 2, I will be
ma'am.
I
1,
will be 1
J will be 1.
and J will be 0. It is A. Okay.
Okay. Yes, ma'am.
So then you will be taking value 1 0 and set it to 1, right? So
Yes,
1 0 will have 1 here.
1.
So at the end, our matrix will look like 0 1 1 0, right?
Yes, ma'am.
And then you will return the matrix. Understood this pseudocode?
Ma'am, can you explain it once again, ma'am?
Okay. See, let's consider this one only. Okay. This is the trains dictionary that you will be passing as the parameter to procedure, right here in direct routes. Then you are creating a empty dictionary, and for each t, so this t will iterate through keys of train, right? these. Okay, so T will take train 1, train 2. Next, what it is doing, it is it is holding those values to stations dictionary, right? So in stations dictionary, you are setting trains T start. So trains T start, what is that? A, right?
Yes, ma'am. Yes.
So A will become the key here and true will become the value in station, right? True will be the value and you will be taking A and B for these statements, correct? So that's why station will be having A and B with the values set to true, right?
Yes,
Now
ma'am.
N is taking the length of the keys of stations. So it will be 2, right? 2 keys are there. Next you are creating the matrix, which is n cross n, which is 2 cross 2. Then station index you are initializing in empty dictionary. Here you are setting the values 0 and 1. Okay, so what you are doing here is you are taking every station and giving an index to it. So first value will be 0, station index S. So this S will iterate through the keys of station. So what are keys? A and B, right? So for the
Yes, ma'am.
first value, it will set I, which will be 0, right? Then I will get increment to 1. Then you will be reading B and B will set to 1. Okay? Now you come out of this loop and here you are iterating through the trains key. Now this T will be taking keys of train. So train 1 and train 2. So for train 1, first time, what it will be taking? Station index of trains T start. So trains T start is what? A, right? So
Yes, ma'am.
if I write some like this, trains T start. So T is for now train 1. So trains T start will give me A, right? And station index of A is 1, 0. Okay. So I will be taking 0. Then similarly J will be taking end, right? And end is B.
1.
So this will become B and J will take 1. Then you will set the matrix. So for 0, 1, you will set 1 here, right? Again for train 2, when T becomes train 2, you will be taking the index of B first in I, which is 1. Then J, you will taking the index of A, which is 0. And again do the same thing. It will be for 1, 0, you will set the value 1, right? Then you will return the matrix here. Understood?
Yes, ma'am.
Okay. Okay, so the next thing is you need to find the hop, right? So this hop is nothing but the intermediate stations. So if I say if I want to reach E, right, from A station I want to reach E, then how many intermediate station will be there? Here if I consider this path, then 1, right? If I consider this path, then it will be 2, this one and this one. I will be passing through both of these stations. But for this path, I will be passing through only one station, right? So that is what we are going to find out, how many hops are there. And we will be creating the matrix for that. Okay. Okay. See here, if we consider the matrix that we have made before, the direct matrix. So we are passing that matrix here. Then n will take the length of the keys direct. So it will be 2, right? N will be 2. Again, you are creating a one hop matrix. Now you have created a one hop matrix. So I will take all the rows and J will take all the columns, and also for K, right? We'll be taking the columns here. So why we are taking 3 variables? Anyone?
It is a hop. It is a case of hop. So
We are taking 3 variables because we want to check for the intermediate values, right?
yes, ma'am.
So for your understanding, I am taking a simplest matrix here. So here see, it will check, suppose the value is 0, 0 and k0. Okay. So it will be check the condition if direct ik is equal to 1 and kj is equal to 1. Then it will set the value for one hop. So suppose, let's check whether the direct matrix will be here. So 0, 0. It is not having 1, right? Correct? So
Yes,
one
ma'am.
hop will not be having 1 here. Then if you check for next value, which will be 1. So we'll be checking for ik, direct ik should be 1 and direct kj should be 1. So it will be 0, 1, and here it is 1, 0. So 0, 1, 0, 1 is having 1, right? And 1, 0 is also having 1. So this condition will become true. So since it is true, so you will be setting the value of ij. Ij is 0, 0. So ij, you will set the value to 1. Next, you will look for 1 here, and this will again become 0. So again you will check for 0, 0, which is not 1. Let's skip this. Then it is 1. So 0, 1 is again 1, and 1, 1 is having 0 here. So again this will not be satisfied. Now increment this to 1, and this will be 0, 0. So for I 1 and k 0. So 1, 0 is 1 again, and k is 0 here, and j is also 0. So this will not be satisfied because this 0 0 is having 0 here. Next it will be 1. So I is 1, j is k is 1, 1 1 is 0. So this is also not satisfying. Then you will take 1 here and 0. So this will be, for I it is 1, k it is 0. And then 0 and j is 1. Okay. So this will again set the value for ij, which is 1 1. Now next will be 1. So all will be 1. So for 1 1 it is 0, right? So it is not going to. Okay. Understood?
Ma'am, ma'am, I did not getting it, ma'am. How we taking as a zero and one concept is this.
See, just understand this how we are going, how we are doing this in the pseudocode, right? So you have already this direct matrix. Then you are creating another matrix, and in that matrix you will be setting the value 1 if there is a connection y intermediate station. Okay, so this is just a scenario since we are not having any connected station, right?
Yes,
Okay,
yes, ma'am.
since we are taking only two, A and B, so there are no connecting stations here. So I am just using this for an example so you could understand it. So here you are taking the rows for I and J for the columns, right? Then again you will take K. You are using three variables because you need to check for the intermediate station. So if there will be a connection, then you will set it to 1. Okay. So for I, K, see what here we are doing. If it is 0 0 0, then we will check for the direct matrix. Okay, we are checking this condition in the direct matrix. Okay,
Yes,
so
ma'am.
we'll be checking for I, K, and KJ. I,
Ma'am,
K, and J. This is the connection between I and J. Yeah,
ma'am, direct matrix is of 2 cross 2. So how can it be means there is a k variable, third variable?
K we are taking the columns, right? So whether you take 3 cross 3, 4 cross 4, K will be the columns and J will also be the columns and I will be the rows.
Ma'am, ma'am, is there any physical interpretation of this matrix, like direct matrix? They are telling that it is one when there is it is when there is station K which is connected by two trains. Then can you explain that logic behind the matrix, or is it something which doesn't have any meaning?
Everything has a meaning. You cannot write a code without any logic. So I'm trying to say I'm just using 2 cross 2 matrix, but if I use bigger matrix, it will be more confusing. So I'm just trying to make you understand this. This K represent the connection between I and J. So here I iterates through the rows, and these I and K is iterating through the columns. Okay.
Ma'am, in the direct matrix, what does direct 1 comma 0 equal to 1 mean? Like, what does it mean?
You
Direct
say 0 and
here
1 is connected when it is 1, ma'am?
Yeah, that is
0,
what.
yeah, come again.
Ma'am, in the direct matrix, we are having only two values in the matrix equal to one. What is the meaning? Like, what is the meaning behind it? Like, 1 comma 0 is equals to 1 and 0 comma 1 is equals to 1. What is the meaning behind it?
You are having a direct roots. You are finding a direct root. So A and B are connected.
Okay.
This is a adjacency matrix. You are what you can say, A and B are two stations, and if from A to B it is showing 1 here, so you are creating an edge, right?
Yes, ma'am.
So this is how the graph will be formed.
Okay.
Ma'am, it's like a checking where there is a edge or not.
Yes, yes, correct. We are checking the edge. Okay. Is this clear? One hop.
But in this connection, ma'am, there is no hop now.
Yeah, you are only having a direct station. Two nodes are there, right?
Yes, ma'am.
Okay, let's see one example. Let's say you are having stations A, B, C, D. And suppose the direct matrix is something like, okay. So from A to B there is a root, from B to C, and from C to D you're having a root. Understood? Now n
Yes.
is 4, you are creating a matrix 1 hop which will be 4 cross 4. So let's say for I0, J and K. Now what you are going to do? You are checking this condition here. This one. For IK and KJ. So IK will be 0, 0 and JK. Again it will be 0, 0, right? So there is no 1 for 0, 0. So this will remain 0 here. Next you will be taking 1. So this will become 1 and wait, this is KJ. So K will be 1 and this will be 0. So 0, 1, 0, 1 is having 1 here, right?
Yes, ma'am.
So both of these condition will become true. We are using AND here. Now the one hop will have the value 1. Right? One hop ij. For ij you will be setting the value. So ij is 0, 0. So for 0, 0 it will be 1. Okay.
Yes, ma'am.
Next you are incrementing this and this will be 0. So for again 0, 0, this is 0, right? So no need to check for the further condition. Now this is 1. Wait. This is 4 cross 4 matrix. Okay, we will be going through each iteration. So we have checked till 1, right?
Yes,
Now
ma'am.
let's say 2. So 0, 2 and 2, 0. So there is no connection, right? 0, 2, 2, 0. No connection.
No connection.
So you will be discarded. Next is 3. So 0, 3 and 3, 0. Again no connection. 3, 0. Right? Then you will be taking here 1. So again this will iterate from 0 to 3. So now this is I is 0 and k is 0. So 0, 0 is not having value. So this is discarded. Then for 1, 0, 1 and this is 1 and k is again 1. So 0, 1 there is a connection, right? Then
Yes, ma'am.
for 1, 1, 1, 1 is
Zero.
not having.
Yes.
This will again be discarded. Next is 2. So for 0, 2 and 2, 1, right? For 0, 2 there is
No.
no connection. Again this will be discarded.
Yes, ma'am.
So similarly you will check for the further iteration. Is this clear how we are doing it?
Yes, ma'am. But ma'am, here
Ma'am,
ultimately we are giving one in one hop when means only for ij
Yeah, for ij will be taking.
at the point where ik is one and kj is one, we will one hop for ij
Mm-hmm.
as one. Yes, ma'am.
Yes.
Okay. Now I understand.
So here
ma'am, in this
before
case,
this for each k, you will be adding this one also. So since if suppose there is no connection, right? But still there is a direct route. Okay. Suppose from A, B, there is something like this. Okay. So to go from A to B, there is a direct connection, right?
Yes, ma'am.
But for D, there is a one hop here.
Yes, ma'am.
So to consider this one also, since there is a root, so here we are taking whatever there is in a ij matrix or direct. Okay. So first you will storing those value whatever there is in a direct matrix. Okay. So if we consider this one, so for 0, 0, what is the value? This will be
Zero.
0. And for 0, 1, it will be 1. Then again you will check for the condition here. If it is satisfied, then you will be replacing the value to further whatever it
So
is.
initially one hop will be as direct matrix.
Yeah.
Okay.
Okay. Any doubt?
ma'am,
Okay.
initially the 0, 1, 1, 0 you are put it as 1, but then here 0, 1 there is a value of 1, but 1, 0 it is still 0 only. So it will be 0 only, right? In one hop.
Come again. I am not able to hear you properly.
Initially, when we were doing that one hop matrix,
Mm-hmm.
0, 1, 1, 0, uh, that where k was 1 and j was 0, that
Mm-hmm.
that you had written the matrix as 1 in the 0, 0 column.
Okay.
One hop matrix.
But here 1 0 is also zero, ma'am, in your matrix. That's why I think
Yeah.
so.
So that is what I was thinking why 1 we got it in the 0, 0, 1 hop matrix.
Yeah, there will be
Take
zero.
one of the example. If I will solve everything here, then we won't be able to complete. Take one example and try to do this pseudocode. Okay.
Okay.
Ma'am, ma'am, for the example which we took previously for train A and B, there is no intermediate connection station K. So why are
Mm-hmm.
we getting the one hop matrix 1 and 1 at 0, comma 0, 1, comma 1?
Since there is no connection, you can not take that graph, right? We are only consider. So one hop will be having whatever there is in direct matrix.
Initially, because one hop.
Yeah.
No, ma'am, not in the second, not in the second part of the pseudocode. The first part, the first pseudocode which we saw, there we took this one hop matrix and we took the example, ma'am. So there in the train station in between A and B, there is no intermediate station. So in this one hop matrix, it is showing one and one at 0, comma 0 and 1, comma 1.
Where it is showing 1 comma 1.
Ma'am, here exactly on your slide. One hop, 1 comma 0, 0, comma 1.
Yeah,
One,
that is what I'm saying. Here, this we were not using this code, right? So if you consider this one also, so whatever there is in a direct matrix, it will be same in the one hop matrix. Since you are not having any intermediate stations.
ma'am,
Ma'am, but we are copying all values of direct matrix, na? So since there is no inter hope between two station, so also there is one hope matrix. It will increment to one because we are copying all elements of direct matrix.
You are copying all the elements. So for ij you will be having the value of direct matrix. Then you will check for this condition.
ma'am, since
Okay, let's what you can do is take one example, and since I have explained what the pseudocode is doing here, take one example and try to implement it. You will
ma'am,
understand.
ma'am, actually, the problem, like my doubt is not in the pseudocode, ma'am. Like after the pseudocode, I understood the example which is shown, but the in that I'm having a doubt, like why in one hop matrix, even after having no stations connected intermediate, we are getting 1001 for the previous example, like for the not for the example where it is equal to direct matrix in the first in the previous one.
Implement this one and see what the answer you're getting. Okay,
Answer
so
is what?
for two hops, let's see for the two hops. So what you are doing, let's see what is the pseudocode for two hops. Here, see, the same thing as we are doing here, just one change is whatever you are storing in the one hop, it will get stored in the two hops, right? And everything will be same. You are using three variables and k will be the intermediate one. And then you are assigning 1 whenever the condition is getting true. Okay. So similarly, if you want to create for n hops, so for n hops, you will be taking what the n hop that you have considered before, right? So here see, one more hop, in one more hop you are taking n hop. So suppose you are creating uh, fifth hop, right? So you will be taking n hop, which is 4 hop, right? The values that you have stored in the previous hop, it will come to the this new one more hop, and this, everything else will be same. Okay, understood?
Yes.
Yes, ma'am.
Now we'll be seeing edge label graphs. So edge label graph says each edge will be associated with a label or weight. Okay. So label on edges can represent various types of info. There could be distance, cost, time, anything. But if you consider the standard graph, so the standard graph don't have any additional info associated with them. Okay. So let's say there is a city 1, city B, so this is uh, the label that is associated with the edge. So we can say this represent the distance between two cities. Okay. Wait a minute. Okay. Now let's take one example. Okay. So if we consider this, let's see the pseudocode. So here we are creating the labeled. Okay. Okay. So we are creating a labeled graph here. So what it has the start, the end, and the distance. So if we so this will be similar to what we have done in direct routes. Okay. So first you will be creating a stations dictionary. The stations dictionary will have the stations, right, that are mentioned in the trains dictionary. So what we have here, how many stations will be there? A, B, C, right? And the values will be set to true. Okay. Now you are taking the length of the keys of station, which is 3, and now here you are creating a direct distance a matrix, okay, which will be 3 cross 3. Now again here, see, here we are creating a station 2 index. So it will be similar to the station index. So we will be creating the station 2 index, which is having value for A 0, for B 1, and for C it will be 2. Okay. Now here what it is doing for each T. So T is nothing but the keys in train, which will be train 1, 2, 3, 4, right? And you will be taking the values in I and J, right? So if I consider the first one, T train 1, so I value will be it is starting from A and ending at B. So for I it will be 0, J it will be 1. And then you are checking the condition. If direct distance matrix is holding the value 0 for ij, so when you create the matrix, it will be initially 0. Okay. So here direct 0 0, you will check the condition first. It is 1 or not, 0 or not. Okay. So it is 0. Then you will be setting the value according to train's t distance. So what is the distance here? It is 2, right? So here in direct distance ij, ij is what? Direct distance 0 1, we are taking the value of this distance, which is 2. Okay. So 0 1 will get updated to 2. Now similarly for every key you will be checking this condition, and then you'll be setting the values according to the distance. Suppose the suppose the value, the I and j row and column, it is holding some value there in the matrix, then you will be taking the minimum of distance and the matrix value. Okay. So if we solve this further, so train 2 will take value B and C. So B is 1 and J is 2. Now it will check. So 1 comma 2 is having 0 value here. So we'll be setting up the value for 1, 2. Distance is 3. So for 1, 2, it will be 3 here. Next we have train 3. Okay. So for train 3, you have AC and distance is 5. So A is, so I will be 0 and J will be 2. So for 0, 2, you will set the value 5. 5 is there? Yeah. So for 0, 2, it will become 5 here. Next, for T train 4, you are having B and A and distance will be 1. So B is 1 and it is 2. B and A. Okay, B and A, so it will be 0. So for 1, 0, you will set the value. So for 1, 0, it will be 1. So here you are not getting else condition. Your matrix will look like this. It will be 0, 2, 5, 1, 0, 3, 0, 0, 0. Okay, understood? Hello?
Yeah, I'm not getting it.
Ma'am, can you take the example of the else condition?
Yeah, I will take. This, let me explain this again. See, you are taking the same thing that we have done in the direct routes, right? Here. So only thing
Yes,
that has changed, you are uh, checking the condition here for direct distance matrix. So you have created a direct distance matrix which will be 3 cross 3. So this ij will hold the distance value of trains. Okay.
yes, ma'am.
So if I say T is some train 1, then I is holding the value AB. So it will be 0, 1. So for 0, 1, you will set the distance 2. Correct?
Yes, ma'am.
0, 1, you will set 2 here. Now for train 2, it is BC. So B is what? 1, right? B is 1 and C is 2. So for 1, 2, you will set 3. So 1, 2, here the value will update to 3. Again for train 3, it is 5. So A is 0 and C is 2. So for 0, 2, you will have 5. So here 0, 2 will have 5 here. Then you have B which is 1, A which is 0. So for 1, 0, you will set the value 1. So here 1, 0 will have the value 1. So this is the matrix you are getting. Understood?
Yes, ma'am.
Okay. So now let's take some example where we can have else condition. Okay. Suppose there is a train 5 and it start from B and end at C and distance is 5. Okay. So B is what? 1 and C is what? 2. So let's see for 1 and 2. So if we check the first condition, the direct distance 1, 2. Is it 0? No, right? It is having 3 here. Okay. So it is having 3 here. So if I check this condition, it will be false. So in else part, we are taking the minimum. So in ij, I will take minimum of the distance, comma, whatever is stored in there. So distance is what? Distance is 5 here, right? So if we take 5 comma 3, what will be the minimum? 3, right? So it will remain 3 here for direct 1, 2. Okay. But if suppose you are getting the distance 2, then this will getting updated to 2. Okay, that is what this line is executing. Understood?
Ma'am, can you please tell how was it 5 initially? I didn't get it.
It was 3 initially. We were getting a matrix like this, right? Here it is 3, and I
Yes,
was
ma'am.
taking a train 5, which is also going from 1 to 2, and the distance is 5.
Okay. Okay.
Okay. Any doubt, anyone? Go through this pseudocode and take example for better understanding. Then you will be able to get it. Okay. Now let's take, we will be doing for one hop, right? How one hop is working. See here, we are taking the same matrix that we have created. What's the value? 02510. Okay. Now here, see, again you are taking the length of the keys of direct distance matrix. So n will be 3, and you are creating one more matrix, one hop distance. It will be 3 cross 3 matrix. Next, you are iterating through the rows and the columns, right? Here you are taking whatever there in direct distance, the same value will be getting stored for I and j, right? So suppose when you created the matrix, the values will be 0 here. Now suppose if I take I0 j0, so 0 0 will take whatever there is here. So it is 0, right? No need to change. Now k in columns. K will iterate from 0 to 2. So first we take 0 value, and here you will check the conditions for I, K and Kj. So for I, K, the value should be greater than 0, and for Kj, the value should be greater than 0. Okay. Now, we are taking a variable which is storing the value, the sum of those values I, K and Kj. So since the condition is not getting satisfied, right? Here both are having 0 values and it is not greater than 0. So the condition is not getting satisfied. So this will not getting executed here. Again you will check for one hop distance here, 0 0. Is it greater than 0? No, right? So you will skip this. Wait. Okay, this will not be going to loop. Yeah. So you will be iterating through the next value. It will become 1 here. Now you will check for 0 1. 0 1, it is greater than 0, right? Then k is 0, k is 1 and j is 0. So it will be for 1 0. So 1 0 is again greater than 0, right? So now you will be holding this value in new distance variable. So new distance will take 2 plus 1, which is 3, right? And now you will be checking the value. Is it greater than 0 for ij? So before we have, okay, so here ij is not having the value greater than 0. So this condition is not getting satisfied. You will be coming to else part, and here you will store whatever is in new distance variable. So 3 will be getting stored here. Okay. Then again you will check for other iterations. So we go for 2, then 3, and you will be updating the one hop distance matrix. Clear? Okay, so why we are doing this here? Why we are checking whether it is greater than 0 or not?
See if there is an edge.
Mm-hmm. Yeah. It is to check whether there is an edge between the I and J vertex. Then why we are taking the sum of this?
Because in one hop there is an intermediate, like if there are intermediate station, then you have to, if you're calculating in one hop distance, you have to calculate the addition, add both the distances.
Yeah. If something is like from I to K, it is 2, and from K to J, it is 1. So to reach I to J, you'll be storing the value 3, right? And then here, what you are doing? You are taking the minimum. So suppose in the before example we have already seen, if you are having the values, the distance is there, and there is already a value in the matrix, right? So you'll be taking the minimum of them. So that is what we are doing here. And if it is not, the value is not there, so you will be going to the else part, and whatever the sum is you are getting here, that is what you are going to be stored. Understood?
Ma'am, this latest whatever you taught, can you please repeat?
Sorry.
The last whatever you taught, can you just repeat?
Okay, I just mentioned that this is storing the minimum value. If you are having something in the matrix, then you will take the minimum of neo distance and the matrix value. And if it is not, if you are having 0 in the matrix, then neo distance will be getting stored.
Okay.
Okay, go through this once. Any doubt, anyone?
Ma'am, if the question has a zero, then we will consider it as a false. No, ma'am.
Uh, where 0?
No, ma'am. It's given in pseudocode. But
Mm-hmm.
then we will suppose that will getting false.
Yeah, it will be false if it is 0.
Yes, ma'am. Thank you, ma'am.
Okay.
Ma'am, will there be an additional session for practice assignment discussion
Practice assignment.
or discussing any doubts because I'm not yet solved the practice assignment. I'm sure many of us wouldn't have
You will
solved
be
it. So will
having
there be?
upcoming session, I think.
Ma'am, regarding the quiz two, you were asking before I could answer. I was just I couldn't answer that question. This, regarding quiz two, there's one last question, which question number 16, I think, regarding that the word, which word, y dot word will return false. Actually, I felt that there was an error, maybe. Is it possible? Can you take out that question, ma'am?
Question number 16.
Yeah, the
Yeah,
last
I
one.
will ask the team, whoever will be taking the quiz 2 doubts. Okay.
Okay.
Okay, so someone mentioned, so someone was saying that here A and B is the only vertices and why we are getting 0, 0 as 1. Am I right? Someone
Yes,
was
yes, ma'am.
asking this. Okay. I think there is a slight change in this pseudocode. You for K, I think you will be iterating till J only. Then I think you won't be getting the values.
Yes, ma'am.
Yeah. So for this one, please correct. This will be J. Here it will be J. So K will be iterating till whatever the value of the J is. So if I 0, so if J is 0, then K will only iterate till 0. Okay. If it is 1, then it will iterate for 0 and 1. Then for similarly for 2, 0, 1, 2. Okay.
Yes, ma'am.
Okay. Any doubt, anyone till here?
No, ma'am. Continue, ma'am. Next talk.
Okay. So you will be having, there are two kind of this algorithm, Delman 4. So the difference between them is this will be taking only the non-negative values. Okay. And this will be taking the negative values as well. I think for the next week you will be reading about DFS, depth first search, and the breadth first search. So depth first search basically go vertically and breadth first search horizontally.
Gently.
Okay.
Yes, ma'am.
Mm, yeah. I think I discussed everything here. Yeah. So, okay. So for n node graphs, in graph, if you are having n nodes, then you will be having at most n minus 1 edges. Okay.
Ma'am, can you explain that more than one hope graph, the pseudocode?
More than one. Okay. This. See,
Yes.
before what we were doing, we were if we are considering the one hop, then here in if you are suppose you are having this matrix and you have already uh, taken the values of one hop. Okay, there is a matrix you have created for one hop. Now you want to go for two hops. Okay, if you are wanting to go for two hops, then you will be considering this one hop. Next, if you want to consider about three hops, so you will be considering the two hops matrix. Similarly, for n hops, you will be looking for the n minus 1 1th hop, right?
Yes, ma'am. But there is a written in n half.
Yeah. So this n will be getting replaced with whatever. Suppose you are taking for four hops, then this n will be replaced by 3 hop I and j value. Okay.
Yes, ma'am.
And everything else is same. The condition will be same. Understood? Hello?
Yes, ma'am.
Okay. Okay, so here also we have discussed edge label graphs. So this is clear, right? How we are creating direct distance matrix, and we are then using this one hop pseudocode, right? Understood, everyone?
Yes, ma'am.
I think here also it will be j. Here also you will be iterating till j. Otherwise it will take the values for 0 0 as well. Okay, then let's move on to questions. Okay, this is clear, right? Adjacency matrix is a square matrix we have discussed, right? Then symmetric. Can someone tell me what is symmetric and asymmetric? Anyone? Have you gone through The content of this week.
Ma'am, is it like 0, 1 and 1, 0 should be the same?
0 and 1 0.
Should be the same, like IJJI.
Yeah, and what about the remaining values?
No, you were asking about the symmetric, right? This one.
Ma'am, it has one single key. Ma'am, ma'am, it has,
Give
ma'am,
me a
symmetric
minute.
has,
Yeah, wait.
ma'am, single key has, it's a symmetric has a single key, and asymmetric has public and private two key.
Yeah, tell me.
Ma'am, symmetric has a single key of encrypted
Mm-hmm.
and decrypted, and asymmetric has, ma'am, two types. One public and private, encrypted and decrypted, ma'am.
No, I am talking about the matrix.
Ma'am, if the weight of the edge from I to j is certain value, then symmetric means the value of j of weight of the this of edge from j to I also should have the same value. But that is not necessary in an adjacency matrix.
So suppose this is a matrix A. Okay. So if you want to check whether the matrix is symmetric or not, you take a transpose of it. Okay. The transpose is nothing but whatever is the row, it becomes a column. So if it is like this, I will write 1 0 0. This becomes column 0 1 0, then 0 0 1. Okay. Is it identical?
Yes,
Hello?
ma'am.
Is it right?
Yes, ma'am.
Yes.
So
Yes, ma'am.
this matrix is symmetric. And there is something called skew symmetric also. So if you get the transpose of the matrix with a negative value, right? So you suppose there is a matrix A, then you will be getting something like minus A, whatever there is the matrix. So A transpose will be equals to minus A. But here the transpose is equal to A. Okay. So that is what here question is. Adjacency matrix is always symmetric. Is it symmetric always? No, right? Here you are getting, suppose, uh, okay, here you are getting this matrix, right? This is also adjacency matrix. So if I take the transpose of it, so it will be what? This row will become column 0, 2, 5, 1, 0, 3, then 0, 0. Is it identical? No, right? You're not getting the same values. Here it is 2, 5, we are getting 1, 0. Then here you are getting 2, it is 1. So it is false here, right? You're not getting symmetric always. Understood?
Yes, ma'am.
Yes, ma'am.
Okay, now what is this question? Consider the table generated from a graph. Names of the station, entries in each cell are distance covered by trains from starting station to ending. Here the starting stations for trains are mentioned in the rows and the ending stations are mentioned in columns. Okay, the starting station is mentioned in rows. This and columns are the ending station. 0 represent that there is no direct train between these two stations. Analyze the table. Okay. So if we convert the above table to a graph, then we will obtain a directed graph. Okay, let's see what graph we are getting here. So we have four stations A, B, C and D. Here from A to A it is 0. A to B 100. Then A to C and A to D is 300. B to D is only having the edge. C to A and C to B. C to A is 500, C to B is 600. Okay, this suppose it 600 and 500. Then D to B. D to B is already. So are you getting directed graph? Tell me.
Yes, ma'am.
Are you getting here the
Yes,
directed graph?
yes, ma'am. Directed graph.
Can you explain?
There is a
Ma'am,
relation.
because
Yeah, because
the relation between A to B, it is in sorry, I think it is undirected graph. A to B and B
uh,
to A, the same relation is there, no?
what do you understand by directed and undirected?
Directed means from A to B there is a relation, but it is not the same relation as in B to A.
Okay. So what are you getting here?
It is same, no, ma'am, in both the directions.
Ma'am, you have to put arrows here because A to B is 100. It's like leading to B, there should be an arrow there towards B.
Yeah, yeah. We have A to B, then A to D. D to D. C to A and C to B. C to A, C to B, and D to B. Yeah. Now tell me.
Now it is directed graph because the relation from A to B is not same as from B to A because this is starting and ending station.
Mm-hmm. So you're telling me that because we are having both the paths from D to B and B to D, so it is directed. Is it?
Ma'am, there is an edge from A to B, but there is no edge from B to A.
There is a edge from A to B, but no edge from B to A.
B to A.
Then it is directed.
Yes, ma'am.
Directly. Yes.
Okay, what about this? If you consider only this part, then
Then it is undirected, ma'am, because from B to D and D to B both are same.
mhm. So you will be considering the maximum things, right? So there is an edge from A to C to A, right? But not from A to C. Similarly, C to B you have edge, but not from B to C, right? B to C you are having edge? No. Correct? Then from A to D also you can see, and A to B. Right? Understood? So answer is true. You are getting directed graph. How many edges will be there in the graph? How many edges are there?
6.
So exactly 6 is there. Then what is the minimum distance a passenger has to travel from station A to D? What is the minimum distance? A to D.
200 via B.
200. Yeah. Here 100. Then from here it will be 100. So total will be 200. Right? You won't be taking this route, right? Then minimum distance from D to A. D to A, what is the minimum distance?
600.
Mm-hmm.
There is no edge.
No edge, right? How can you go
There
from
is
D
no
to A?
edge. Yeah, there is no edge. Sorry.
So traveling is not possible.
Ma'am,
Mm-hmm.
ma'am, for the directed and the undirected graph, if we get the 3, 3, like you told us to get the maximum, but if there's a case like 3 are directed and 3 are undirected, so then
Three are directed and three are undirected.
so what we have to consider, like
Then you can consider it as undirected only. The worst possible case you go for. Okay.
yes, ma'am.
Okay. Okay, let's solve these questions in the next session. Okay. Any doubt in the concept?
Ma'am,
Mm-hmm.
please add the videos in calendar video link also. YouTube link.
Yeah, I will upload in the recording.
Ma'am, in
Ma'am,
calendar, ma'am.
Calendar you must be having, no? The
ma'am, it is
session or
not there in the
already.
calendar, ma'am.
Okay, okay, I will
Yeah,
ask them. Okay, I'll ask them.
Also, it is not there on the YouTube channel also. I checked it. It is not streaming live on YouTube.
Yeah, we are not streaming live. It is getting recorded. since there is no power in Chennai.
Okay.
Okay. Okay, then
Thank
thank
you,
you,
ma'am.
everyone. Okay, thank you.
Thank you,
Ma'am, it
ma'am.
was nice session.
Okay, thank you.